So we'll talk a little about analog integrated circuits. Typically, it's operational amplifiers. There's a mistake on the second line. It should just be MMICs. And then we'll talk a little bit about packaging for some of these devices. So what is an analog integrated circuit? It's just a circuit with linear devices where there's more than one on the substrate, which makes it an integrated circuit. Otherwise, it would just be a transistor or a diode. Typically, it's going to be a voltage regulator, an operational amplifier, maybe a wideband RF amplifier. That's where the MMICs come in. Or it could be high pass, low pass, band pass filters. So what kind of device? Well, all right. Well, everybody knew that. What kind of device is an integrated circuit operational amplifier?
I think it's
I
analog.
gotta clean my mouse. It's getting a lot of double bounces. Okay, so an MMIC is a special type. It was created for doing microwaves. They're also useful at HF frequencies. That radio I'm building uses those as a preamplifier in the RF stage. They're designed to operate in a 50 ohm circuit. In other words, they have 50 ohm input impedance, 50 ohm output impedance, very wide, flat frequency range to go up into as much as 300 gigahertz.
But it says it starts at 300.
Yeah, there's some that work below 300. Trust me. They have a controlled gain. In other words, it's pretty much fixed. It's just a little block, amplifier block. Very low noise figure, 2 dB. In other words, it raises the noise floor 2 dB, which is not much. In dB, it's actually what? 40%? No, guess I said everything there. Normally, you're going to see it in VHF microwave type things. So what is meant by the term MMIC?
B.
Well, now they have multi-megabyte integrated circuits now, but it's not one of these.
I think we're going.
Yeah, I think we're going for Bravo. What characteristics of MMIC make it a popular choice for VHF through microwave circuits?
It's got to be the one with infinite gain. I really like that.
Well, they call those operational amplifiers, but it's not one of those. It is a fixed gain. I think the ones I'm using, it's either 6 or 10 dB. Which is the most common input-output impedance of circuits that use MMICs? 50 ohms. Which of the following noise figure values is typical of a low noise UHF preamplifier? Alpha. Usually they're made from something other than silicon in order to get the speed up. So gallium nitride is one of the materials, sometimes gallium arsenide. Not sure what the differences are between the two. They're very similar. I think gallium arsenide might be a little higher frequency range. I'm not sure. But in both cases, they have higher electron mobility, which I don't understand the physics, but supposedly the charges from moving as electrons migrate and recombine, the movement of those charges is faster.
Or they go into the hole.
Yeah. That gets into physics, and we don't do physics much.
Has to be.
Which of the
fast-
following materials is likely to provide the highest frequency of operation when used in MMICs?
D.
All right, one of the galliums, and they only gave you one choice. Why is gallium arsenide useful for semiconductor devices operating at UHF and higher?
B.
Okay, so when you're using these things, because of the 50 ohm input output, you basically have to connect them up with transmission lines. So if you're doing it on a circuit board, you can use things like microstrip or strip line. In microstrip, it's just a copper on the PC substrate that is designed to create a 50 ohm transmission line. So since you know the dielectric and the spacing, you can, and the thickness of the conductor and the width of the conductor, those are all factors to calculate how to make that a 50 ohm line. And you kind of want to do that to control the impedance and also the length of them so that you don't get phase differences. Like if you're doing I and Q circuits where they have to be 90 degrees out of phase, you want to make sure that you don't get a phase shift between the two and get them out of the 90-degree phase difference. Otherwise, you can't generate or eliminate a sideband when you're doing that type of single sideband generation or detection.
That phase
You don't
difference.
see strip line that much. Go ahead.
That phase difference is going to be frequency dependent, isn't it?
Yes. Well, it's going to be a function of frequency, but as long as the lengths and the impedance is the same, you're going to have the same phase change per unit of length.
Well, but a two strips that are differing in phase would not be for universal frequency.
The phase is going to change the same amount on both of them as you go the same distance. So the relative phase between them won't change.
Well, if
The
you needed
total phase
you
will
needed
change.
90 degree, if you needed 90-degree phase shift between two signals, that probably wouldn't remain the same over frequency, would it?
Oh, correct. At a different frequency, right.
Okay, so it's not a universal phase shifter.
Oh, no. The point was you need to maintain the same lengths so that you don't get a phase change difference between two different paths.
But it's not the answer for DC to daylight sideband generation. You're saying the different phase could be used in sideband generation, and I just don't
Right.
think it's just not universal frequency generation.
Well, in actual practice, what you do is for every band or small frequency range, you actually have to put in calibration to adjust the phase difference.
That makes sense. Yeah.
Yes, trust me, I just did it. And it's a pain in the butt. Okay, so the way you hook these up, and they're kind of oddball in that you supply power to the output. It's basically an open collector or open drain type of device. So you apply a voltage through usually a resistor and a choke directly to the output pin. And these only have, what is it? Five or six pin device. So what type of transmission line is used for connections to MMICs? Microstrip. How is power supplied to the most common type of MMIC?
A.
No. No.
Alpha. Whoop. Alpha. The resistor and the choke.
Yeah.
Because you don't want the frequency on the output getting back into your power source. That's why the choke is there. Okay, we'll talk about packages. So integrated circuits started off in what we call DIPs or dual inline packages, where they had two rows of pins and they were anywhere from a 4-pin up to 40 or 60 something pins. When they started getting beyond that, then they went to other than through hole. And these are basically through hole devices where they actually get plug into a socket or directly soldered on through holes on a printed circuit board. They're very hard to remove. If it's bad, it's easy because you just cut the pins and then take each one out individually. If you're trying to save it, it's a bear.
Oops.
This is just a picture of a standard dip. Huh?
And the dead one is
Yeah, the dead bug. Are you familiar with dead bugs? I
very.
used to glue it on top of that one and then run wires. But I don't think their purpose was a dead bug, just showing you the bottom. What's the characteristic of dip packaging used for integrated circuits?
D.
Delta, all right. Which of the following device packages is a through-hole type?
A.
All right. This is showing a variety of modern devices. Either, well, they're all kind of surface mount.
This one.
Which one?
PGA. Is your PGA on it?
Oh, well, yeah. Those are processors though. Processor chip. What? Really? Okay, so one of the reasons why things have switched over to surface mount is
Excuse me a
get
second.
rid of the excessive lead length that you'd have in a through-hole device. So you can get rid of that extra inductance. You can operate at much higher frequencies. Their packages are much smaller, so you can make it more compact and I guess generate less heat. The manufacturing process is actually easier than trying to place through-hole devices and wave solder them or whatever. doing surface mount devices with the right tools and knowing how to do it is easy, especially removing them, where through-hole devices are not easy to remove. So you have less parasitic inductance and capacitance. Just a whole lot of advantages. But if you're old and got bad eyes, it's hard to do. Fortunately, I'm old, but I got good eyes.
And you really need the right kind of tools to.
Yes.
Yeah.
You don't use well, you can do 1206 size with a regular soldering iron. Small tip. And magnifying glasses. And tweezers. Otherwise, it blows off the board, or well, it wouldn't blow off, but it's easy to lose. Why are dip through-hole package ICs not typically used at UHF and higher? Charlie. Which of the following component package types have the least parasitic effects at frequencies above the HF range?
David,
What advantage does surface mount technology offer at RF compared to using through-hole components?
D.
Go.
All the above? Yeah. Okay. That was an easy